So for today's lesson, we're going to be going over a new concept called probability now. Probability involves, well, I guess you would call them fractions. You've taken a look at that before. So that's like something over something, or you could think of it as a percentage. All right. Now, we'll talk about how to do that during today's lesson. Well, not today's lesson, but we'll talk about how to turn fractions into decimals during today's lesson. So in this unit, you're going to determine the probability of an event. You're going to perform probability experiments. Okay, so theoretical probability experiments. And then you're going to use a frequency distribution, i.e. tabulation of different events that happen, and use distributions, i.e. graphs, to show what's actually happening during the experiment. You're going to be able to compare theoretical probability with a thing called experimental probability. Then we're going to observe how experimental probability is going to approach theoretical probability as we increase the number of times we do something. We're also going to interpret the information involving the use of probability and statistics in media. So media meaning Facebook, media meaning, well, newspapers, things like that. Key concepts that I want you to focus on are data and statistics, experimental probability, and theoretical probability, and then the concept of an event, an outcome, and what we call a trial. We will use that as part of the definitions testing near the end of the unit. All right, on to prerequisite skills. All right, before we do that, let's go over some usual things. So let's say you see something like this, 0.1357 on a calculator. We will say this is the same as 1 over 10 plus 3 over 100 plus 5 over 1,000 plus 7 over 10,000. You can also rewrite this like this. Well, you still have the 1, the 3, the 5, and the 7 represented, but we would write this as times 10 to the negative 1, and then plus 3 times 10 to the negative 2, plus 5 times 10 to the negative 3, plus 7 times 10 to the negative 4. Let's just make one last little correction. This should be 5 to the 1,000 and then 7 divided by 10,000. We call each of these things in our calculations, each of these numbers in here, digits. All right, so first problem, we're going to take a look at fractions, decimals, and percents. So let's express each fraction as a decimal and not use a calculator. So 53 over 100 becomes 53 divided by 100. Now, all we have to do is remember that this, when we divide by 100, it means move the decimal 2 places. 2 places right. So for this case, if I look at the 53, the decimal starts here to the right of the 3, and we move our decimal over 1, 2 spots, so it's 0. So the decimal ends up being here. So we can write our final answer as 0.53. Make sure you put a 0 in front if it's not there. Now we can do the same for the next problem, but this time we have to change our problem into something that looks like 100. So if I look at 4 divided by 5, right? In order to get 5 to equal 100, I have to times it by 20, right? Now, whatever I do to the bottom of the fraction, I got to do to the top. I call that Mr. Simpson's rule of 1, because 20 over 20 is just 1. Anything, something over something which are identical ends up being 1. So now what we're going to do, we multiply the top. So we're going to get 80 over 100. And now we use the same rule as before, which was just 80 divided by 100. And then we take the decimal that is represented here and move it twice over. So our decimal is going to be just before the 80. So now we're going to write equals 0.80. So 0.80. All right. So let's pause the video and do the next one. See if you get it right. So now we have 12 over 20 equals, well, we got to multiply 20 times 5 to get 100. So then we're going to multiply the top also by 5. So now you've got 60 over 100, which gives us, well, 60 divided by 100. And we're going to move our decimal over 2 spots. So it's going to be 0.60. 0.60. And because there's no number in front of the decimal, we just put a 0. And we're good to go. All right, so the next concept that we have to focus on today is a thing called decimals and rounding. Some of you guys had some difficulty with rounding on the last set of the assignment, and I just want to make sure that you know how to round. So this problem has asked us to round to 4 decimal places. So 4 decimal places, and we're going to use our calculator. So on our calculator, we know that this is just 17 divided by 32. Now, we're going to round this to 5 decimal places. So here's what I want you to do. Every time you have to round to 4 decimal places, 4 decimal places, you must write 5 of the decimals. So in this case, 17 divided by 32 is 0.53125. And you'll notice that I'm always going to put dots after. So X number of dots. So in this case, I'm just going to make sure I put my 4 or 5 dots to kind of tell myself that there is a possibility that this goes on forever, right? And you'll notice that when I'm rounding, I'm actually going to make sure that I basically look at 5 decimals. Okay, because what we're focusing on is the second last digit of those 5 decimals to determine whether we round up or down, right? So because we have a 5 after the 2, we're going to write our final answer as an approximation, that equal sign with a dot above it. You're going to write 0.531 instead of a 2. Because we have a 5, we have to take the 2 and tack on 1, which means we have 0.5313, and there is our answer. So now let's do the same for 1/9. We go and use our calculator, and we take 1 divided by 9, and we get 0.11111. Now, this is going to go on forever, so I'm going to put dots here. And you notice, because we are rounding to 4 decimal place, we need 5 of the decimals to do our determination. And now, this spot here is what we're going to look at, right? Because we have 9 divided by 1 divided by 9, that's our spot, and we are looking at this number here, the 1, okay? That 1 beside us tells us that our final 1 in our decimal is going to be 0.1111, and that's it. Because it's less than 5, we leave it. We let it rest. So let's say we have 2 divided by 9. We'll do it again. 2 divided by 9 is 0.22222. Notice I said, because it's 4 decimal places, I have 5 2s. Now I know I'm going to look at my last decimal, second last decimal, and I'm looking at the very last one to determine whether I'm going to round it up. Because this number here is less than 5, right? is less than 5, so 4, 3, 2, 1, or 0, that means the final answer is just this block here. So we just write 0.2222, and there is our final answer. All right, guys, listen, I'm really sorry that I had to do this. I have to be very, very, very explicit, as some of you guys are having difficulty with rounding. So just pay very close attention to all this stuff that we're doing, okay? And if you have to go back over that stuff that we did before. All right, so let's go and take a look at expressing fractions in lowest terms. So let's make sure that we have this information here above. So 0.8. So if I can write 0.8 as 0.80. And we know that we can take 0.80 and turn that into, well, 80 over 100. Okay, so here's the rule. This spot here is tenths. This spot here is hundredths, right? So once we have two decimal places, there are hundreds in it. So we say it's 80 over 100. Now, here's the best part. Now, in order to make this stuff be lowest terms, what we have to do is we have to look at the largest number that divides 80 and 100. And both of these can be divided by 10. 80 divided by 10 equals 8. And 10 divided by 100 is 10. And now take a look. We can divide 8 and 10 both by 2. And we end up with 4 over 5 as our final answer. So now let's take a look at 0.85. So here is the rule. Remember, this portion is the tenths, and this portion is hundredths. Now, because we have tenths and hundredths, we can write this as 85, and because the last digit represents the hundredth spot, we can write this as 85 over 100. And we already know that all we have to do is we look at the number that both divides the top and the bottom, and the number that divides both the top and the bottom in this case is going to be, well, both numbers can be divided by 5, I guess. Let's try 5, because 5 can be, anything divided by 5 can be divided by 5. Anything with a 0 can be pretty much divided by 5. In this case, our final answer is going to be 17 divided by 20, and there is nothing that we can do for this. Now, for 0.666666, right, we can always remember that this is just 6 over 9. Just like how we had 1 over 9 equals 0.11111 infinite, this could be 2 over 9 is also equal to 0.22222 infinite. So that means 0.666 infinite is just 6 over 9. So now, since we have 6 over 9, let's go and divide both the top and the bottom by 3. The top and the bottom by 3 gives us 2 over 3, and we are done for our final answer. Just put a box around your final answer when you're done. And now let's move on to example 4. So example 4 is talking about expressing percentages. So when you hear the term percent, right, or you see this symbol here, right, we're saying that percent means out of 100. That's all it means. Percent means out of 100. Now, the reason why we use the percent sign is that there's the 1 and there's the 2 zeros for the 100. If you can remember that, you'll know that you can write this as a decimal and then turn our decimal into a fraction. Right? So when we have 20%, what we're literally going to do in order to turn this into, so to turn into decimal first, what we have to do is move the decimal 2 spaces to the right. And then it ends up being a decimal of 0.20. So you'd write 20, and then you would move your decimal to the right 2 spots. So now you've got 0.20 is our decimal. So this represents the decimal. From, what would we call it? The decimal from percent. Okay, so now that I've got that, now we're going to change it into a fraction. So 20% really means 20 out of 100. So I'm going back to the original. So 20% really means 20 divided by 100. And you notice this is the 100th spot. So I could literally, if I wanted to, I'd just write 20 divided by 100, right? And now we divide both the top and the bottom by 20, because both of them can be divided by 20 to reduce it. And we end up with 1/5 as our final answer. So now, what about 75%? So 75%, if we follow the same pattern as before, we just move that decimal 2 spaces to the right, which means we have 75, and moving the decimal, which is here, 2 spaces to the right means our decimal is here, so we end up with 0.75. Now, remember, a percent means, now let's change it into a fraction. So this 0.75 is 75%, yes, right? Now 75% really means 75 divided by 100. Now both 75 and 100 can be both divided by 25, which is the biggest number that can divide both of them. So now you're left with the following answer. Well, 3/4, and guess what? We're done as our final answer. So now we have 33.3%. That thing over the top, that bar, really means that this is repeating. Okay? And because it's repeating, you're going to write this as the decimal. This is 33.3, so we're going to move the decimal 2 places to the right like before. So here was our original point. We move it right here in front of the 3 here, the first 3. So we end up with 0.33, and the 3 repeating means it goes on forever. All right, now we know that any decimal that is repeating over and over from 1 to 9 ends up being the number that's in front. So we end up with 3/9. And now we're going to take 3/9 and divide both sides by 3. And we end up with, well, 1/9. Okay, let's move on to the second page. 2 more parts and we're done. All right, so for these problems, we're going to have to evaluate without the use of a calculator. So for question A, we have 3/4 is 1/8. Now, let's quickly make a quick reminder that this part, the top, is called the numerator, and the bottom is called the denominator. I want you to think of it this way. The denominator denotes how many slices the entire whole makes, right? Okay, and then the numerator is how many parts of the whole we have. So let's go and do this without a calculator. So if we have 3/4, make a space, and then 1/8. Now, the key is to turn the numerator of one of the fractions into the other. So in this case, what I'm going to do is I'm going to look at my 8 and my 4. Now, in order to make 4 look like 8, I got to multiply 8 by 2. 4 by 2. So now that I've got that, I have 3 times 2 on the top gives us 6. 4 times 2 on the first fraction gives us 8. And then we get minus 1 over 8 as our second. Now that we have two of the same denominators, we can either add or subtract them. So now I've got 6 over 8 minus 1 over 8. So my final answer is going to be something over 8. And in this case, it's 6 minus 1, which is just 5. And we are done. For question B, we have 5 times 7 over 18 times 10. Well, what you can do is you can combine, because it's multiplication, it means multiply all the tops. So we end up with 5 times 7 divided by 18, and then times it by 10. Now, because these are eventually going to be two numbers which are on top of each other, it allows us to both divide stuff that both of them have. In this case, you'll notice that we can divide both 1 5 from the top. So 5 divided by 5 is 1. And 10 from the bottom can also be divided by 5, and that gives us a 2, which means our final answer is 1 times 7, this, 1 times 7, which gives us 7, over 18 times 2, which is 36. And you can guarantee that that is your lowest form for our fraction. And we're done. So now, what does it mean to say 1/3 of 24? 1/3, it really means 1/3 of means times 24. Now, because we're timesing, remember when we multiplied two fractions, we combined the tops and the bottoms, right? We can take 24 and represent it as 24 over 1, right? Which means we can write this as, just like before, 1 times 24 divided by 3 times 1. Now, both the 24 and the 3 can be divided by 3. 24 divided by 3 gives us 8. And 3 divided by 3 is 1. So we have on the top 1 times 8, which gives us 8, and divided by 1 times 1, which is 1, which means our final answer is 8. And we're done. Now you'll notice that I have a thing here that's, imagine I asked you to evaluate, right? Evaluate using the fraction button on your calculator. There's an actual fraction button on each calculator where you actually have something over something like this on your calculator, or you'll see something that looks like this, big A to the B over C as our fraction. So try to get yourself familiarized with that. Both of them are very useful in the sense that you'll be able to create fractions and then read them off your calculator. Send me a message if you'd like to learn how to do that. All right, so now let's move on to interpreting data, okay? So this question says, how many people who attended the family reunion were older than 50? So now we have to express our answers as a percent. Okay, so remember that when we're talking about a percent, right, we're talking about, we need to know things like the total number of people that are over 50. So if I'm looking at this problem here, these are the people that are over 50 in this problem set, right? Now, here's the best part. If I write this out, this tells us that the total number of people over 50 is equal to, well, this 3 plus 5 plus 1, which is 9 people. Okay. Now, the total people in the set that are actually here are going to be 8 plus 10 plus 18 plus 15 plus 6 plus 9 plus 3 plus 5 plus 1. And where did I get that? I got that from my chart here. Okay. And this tally, this frequency chart is just, it just allows us to keep track of who is where, who is in what category, 0 to 9, 10 to 19, whatever, right? And in this case, the total number of people is going to be 75 as our final answer. So now if I want to find the percent over 50, you're going to get this. 9 divided by 75 is the fraction, right? But now we have to turn it into a percent. So we have to times this by 100%. So this represents the fraction, and then the times 100% turns it into 100%, right? So that gives us a total of, well, 9 divided by 75 times that is going to be 12%. Now, if I asked you to change this percent into a fraction, you would say 12% is equal to 12 divided by 100. Now, 12 divided by 100 can both be divided by 4. And we end up with our final fraction of 3 over 25. So it says here, express your answer as a percent and as a fraction. So you're going to say at the very end this. The percentage of people over 50 is 12%, or 3 over 25. All right, let's move to the last concept of the day. All right, so now, for example 8, it's imagine that you've got some data here, okay? And that data is in the form of a chart, okay? Now, a chart could be represented as a pie chart, a histogram, actually, i.e. a bar chart, things like that, right? Now, let's take a look at this problem here. It says there's data of about 10,000 students were collected. So that's 10,000 of them, right? The results are shown in the given table and graph. So here's our table. And then this is the result that we have as our graph. So these are the kids that have an A. So remember, these are all the representations of A through F. So we have this where we have 80 to 100, 70 to 79, and all these different parts, right? So let's go and take a look at how many students failed their exam. So if I'm looking for that in our chart, that's this information right here, right? So here is how we figure out the number of people who failed. When you hear the concept of relative frequency, we're talking about the percent of the population as a decimal. When you hear the term relative frequency, we've taken whatever the total number of people is and turned it into a decimal. So in order to find the number of failures, what we have to do is we have to take our 10,000 that we had before, and then we're going to multiply this by 0.056. And this is kind of like our percent as a decimal. And we studied that earlier, right? So now all we're going to do is we're just going to take whatever that decimal is and multiply by the number that we had, the number that we started with, and we end up with 568, which means 568 people failed. Now, let's go and find out what fraction of students failed their final exam. Okay? So here's what you would say. So if I wanted to change this percent, change that thing into a percent, we'd go 0.0568, right? And we're going to times that by 100%, and that gives us the answer of 5.68%, right? Now, if I wanted to find the fraction is equal to the number that failed divided by the total. In this case, we've got 568 divided by 10,000. And that is our answer for our fraction of students who failed. Okay? And your homework is page 58, number 1 to 10.